All right. The recording, I think, has started. I'm waiting. Does it say? There we go. Now it
There you
says I'm
go.
recording. Woohoo! You gotta wait. All that Azure Media Services behind the scenes. That's what's handling all this stuff. So my name is Auri Rahimzadeh. I don't know what I did. There we go. And I own a small company, little consulting company called Auri's Ideas. Um, and I've been developing for a really long time, teaching software engineering for a long time, and I am also in charge of software at a company you might have heard of called Klipsch. They're an audio company here in Indiana. So tonight we're going to talk about debugging. Now, before I get started, how many of you are new to development and that's why you're here, that you want to learn about debugging? Just use the little raise your hand thing in Teams if you know how to do that. Taking a look, just seeing how many people. That's weird. It closed my little participant view. Come on, Teams. It's always fun seeing how Teams handles, so many different people. Okay, so a few of you are here and learning about dev, or probably you're just new to development. So that's good to know. And part of you might not know exactly how the hand feature works. It's over at the top of the screen, but no biggie. Cool. So debugging really, and I'm going to get into this, is such an underrated skill. Super important for you to know. So let me move on here. When it comes to I'm just going to close my screen because I think all my dogs want my attention because I'm talking. If you do want to get a hold of me, I'm pretty easy to get a hold of. I'm Ari on Twitter, super easy. Best way to reach me though is via email. So just ari@ari.net. Super simple. My name at myname.net. So with code or with debugging, one thing that you realize as you're a developer is that code is the easy part. Everyone knows how to code. Even if you're a beginner, you know how to code. You're just going to end up building more and more complex applications. The problem is that code breaks. We rarely write perfect code, um, but code does break, and your real top skill as a developer isn't your ability to code. I look at it as like your ability to write is it really isn't your top skill. Your ability to write eloquently and your ability to correct what you write, those are real skills. So debugging and planning really end up being your top skills, and it's what you'll be doing most of the time as a developer. You'll write your code, and it'll break, or you will be faced with broken code and be asked to fix it. So oftentimes you'll work on code that you never even wrote and you have to fix it. That's debugging. So you need to get used to it. And there's some tricks and we'll go over it. One way I liken this is that code is English, but writing a book is debugging and planning. Anyone can write code just like you could write words, but forming them into sentences and then into paragraphs and then into chapters and then a book. That's where your skills really come into play as a developer, not just a coder. So there's a few different types of bugs that you're going to deal with. Um, I'm sure that we could go outside of this box, but generally they fall into these categories. And it's so important that you know these types and have a sense of situational awareness around all of these different bugs. Because whenever you're brought into a list of bugs, if you're not clear about the priorities, you can get lost, and people may think that you're not responding with a sense of urgency, and you need to provide that perception at least. You should always respond with a sense of urgency and have a sense of urgency, but at least you should have the perception of responding with urgency. So number one, and the most common type, or actually, it might be the least common type, I'm sorry, is immediate fix, critical priority. So these are the items that, a VP of your company has called you, or your technical lead has called you and said, we have to get this fixed now, the system is down. So if you dealt with the internet being down yesterday due to Fastly being down, that's one of those immediate fix, critical priority bugs. No matter what you're working on, you got to drop what you're doing and you got to work on this. Or we're starting a sprint and this is the number one priority and everything else is number 100 in its priority. So these are the items that cost us money, cost us customers. The system is down. So as developers, something that you should consider as well is not just the code side of it, but also the business side. How are the people that are working to make it possible for you to get a paycheck? How is this affecting them? Because it's not just about the code, it's about the services that code powers. Now, after immediate fix, critical priority, you end up having highest priority. So these are the things that don't have to get fixed right away because they're not costing us money or customers. But it's stuff that we need to get done top of the list. If we have a whole bunch of bugs out there, a whole bunch of features, etc., but in this case we're talking about bugs. These are the highest priority ones. For example, this is affecting 15% of our users. And they're dealing with crashes, etc. We got to solve this because 15% of our users have to force quit our app, or they have to reload the page, or the system doesn't act as expected. The system isn't down, you can get past it, but we need to address this. This is very important. So those are the items that you generally need to complete by the end of the sprint. And then everything else, if it's not a high priority, like if you had a range of like 1 through 3, if it's not a number 1, I'd look at a critical as a 0. It's really kind of out of view. Unless you have a team that's large enough to deal with a mix of the two, really you need to concentrate on highest priority first. And then that way you're at least keeping your head above water on the stability of the system and the ability to just keep it running where your customers are generally happy. Now, I think it stands to reason anything lower, it's as you get to them. And to be fair, priority will change. So maybe a bug that came in during the previous week's sprint didn't seem like an issue. And suddenly you realize, actually, yeah, it is a big issue. It's affecting a high percentage of customers. It becomes highest priority. In these cases, just be ready to defend not working on certain bugs. Like if you already have a number of highest priority bugs, just keep in mind that those items that suddenly become high priority, not critical, but those items that become high priority do not need to become higher than the high priority items of the current sprint. So balance it out and be willing to make that argument that if the team is busy and slammed, that, yeah, sure, we have a whole bunch of, we have a new high priority bug, but it may not get done during this sprint. Because if everything becomes high priority, nothing's high priority. It's all the same. So you have to be aware of that as a developer. As a junior developer, you might not be piping up so much about that sort of thing, but no matter what your level is on the dev team, you're responsible for scope. So keep that in mind, that given these types of bugs, that the malleability of the priority is something that you should still watch out for turning into scope creep. So let's go through a few of these example tickets because you're going to get some tickets of a couple different types. There's going to be the typical ticket type and then a good ticket. And just to answer, if you have any questions, just go ahead and put it in the chat, and I'll see it over on the right-hand screen. Well, I mean, you can't tell that it's my right-hand screen, but it'll be there. So I'll look over there from time to time and answer your questions. And I set aside time to answer additional questions when my presentation is complete. So the typical ticket uh, is this. The app doesn't work. When I try to connect my device, it gives me an error. Oh, and I'm on iPhone. Well, okay, to the average user that's reporting an issue that is not a coder and generally non-technical, this seems enough to them because they look at you as a developer. You should be able to just figure it out because you're a computer person and you understand this stuff. But what don't we know here? So does anyone know? Like, put in the chat. Is there anything that we don't know here? Yeah, one thing that we don't know is, well, what version of iOS, what type of phone, like Sherry was saying, um, what time of day did it happen? Yeah, what is it? It gives me an error, like Keith was saying. Well, what gives you an error? Does the phone give you an error? Does the app give you an error? I don't know. Were you in my app when you were trying to connect the device, or were you just in iOS and you can't pair your device with Bluetooth, or you can't connect to the network? I don't know where this issue is. Another good one, same one, Lynn and Alexander, same thing. What error? What's the error? It gives me an error. What is the error? That doesn't help. Just there's an error. Um, and yep, Scott said it too. And then Sherry says, hey, are they running the latest software updates? Another very important one. And if you're doing app development, are they running the latest version of the app? So just a running software at Klipsch, when we roll out an app, and this is out of our control, but when you roll out an app to Apple or Google, people don't, even if everyone had auto update on, they won't all get it overnight. It can take 4 to 5 weeks for the majority of your users to get the app. It rolls out at about 20% a week. So keep that in mind when you're deploying an app, like a mobile app, because I, also present and run the Indy Xamarin meetup. Uh, if you have an important bug fix, the users may not act, you may not see the bug tick down significantly for 4 weeks. Probably at least 1 to 2 before you really start seeing it tick down, just because of that slower rollout schedule. So those are all very good comments, but yeah, a typical ticket example is just like this. So an atypical ticket example, which is what I always ask people, is give me clear details, like repro steps. What's a clear definition of done? Like, I know this is solved when any mock-ups, or screenshots, etc. Any assets I may need to fix it. Like you're saying that the color scheme is wrong on an image or in the UI. Well, don't just tell me the color scheme's wrong. Give me the color scheme or point me to it. And as developers, I do feel it's your job to work with your customer, which is the team and everyone outside of the team. You're a service provider as a software engineer. You're not the help desk, but you are a help center. The people who work with your team are customers, be it customers within your company or customers outside of your company. So if you treat them that way in like a customer service fashion, I think you'll get better results in interoperating with them. It becomes a soft skill. But over time, you should work with people to say, hey, in order for us to get this work done, you must provide us this information. Anything that you can do to set your customers yeah, up for success in this regard would be great. For example, updating your ticket tracking system. If someone's reporting a bug, put the things that you need to know. Like if they say there's a bug, have a field for reproduction steps, have a field for operating system, have a field for additional details with some hints like what you were saying over there. What is your phone model? What's your operating system version, etc. Um, and what error are you getting? Description of the issue, screenshot fields, etc. If you make those fields required, you might not get screenshots. I probably wouldn't make that one required because they might have closed the app or quit it, and then it continued working, and they'll be like, "Damn it, I can't submit a bug because I can't copy in a screenshot." Be reasonable, but by making at least the text fields required, you'll start getting your users accustomed to giving you this information. You're effectively forcing their hand, but you're also building a process that sets you up for success and ultimately sets them up for success because they get their problem resolved. One thing there's any number of ways that you could do this. There's a lot of systems out there that will help you. For example, you could use Azure DevOps, ADO, to handle this. Jira and Jira Service Management, Jira Service Desk. If you're a Jira organization, you could even use Freedcamp, Freedcamp. It's like Basecamp, but better. Or even a SurveyMonkey form or a Jot form, Jotform. Uh, just something that walks them through filling out the form with the required fields, front loading the questions your developers are going to inevitably ask. So, an example of a good ticket. Here's one that I've got. This is actually for a feature process or a feature request, but even bugs are similar to this. But an overview of what the issue is or what the feature is, a clear definition of done. Usually when I create a ticket that's a feature request, I include a low fidelity mockup with it. You don't have to be an artist, but using an application like Balsamiq, Balsamiq, uh, will change your life. Just to give you an example, let me see if I can, like if I was, I don't know if you can see this, but I go through and I walk through what screens are supposed to look like. It's super low fidelity, but I explain it in pictures so that my developers have a picture in their head. Um, Also, be as detailed as possible and ask your users to be the same. So here I have like a screen flow, so there's no question, about like how this needs to work. But reproduction steps, I need reproduction steps. I can't repro this issue. Well, all you gotta do is open the app and it'll do it. Well, but where were you in the app when it happened? Don't assume that I know what you did. I don't live at your home. That would be creepy. Now, as developers, I think sometimes we hold off on asking questions. Um, like sometimes it's it can be there's a little ego involved where you don't want to ask questions because you think you should know how to fix it. I think that's a bad habit. So if you have that habit, I feel you should drop it or work to mitigate it. Uh, Always communicate. Don't wait till the next meeting. If there's a ticket out there, do what you can to be proactive with communicating with the user or the product manager, etc. Don't spin. Once you realize that you've exhausted your resources, don't wait. Recognize when you've hit the end of a rope and say, I need help. Communicate that out. Remember, if you work on a team, your team will support you. Sometimes there's bugs you will not be able to fix. That doesn't make you a bad developer. It means you didn't see a path forward for fixing this bug. There may be people who are more familiar with this area of code. Reach out to them and ask them. Like I was saying before, if you don't have enough detail, accept that fact and reach out for the details. So let's go over some of these items that you should ask for. I kind of covered those earlier, and you did too. But this is how we can prevent the ticket from getting blocked and get to resolution as quickly as possible. So give me a clear description. Give me clear reproduction steps from launching the app to when it crashes. Screenshots, if possible, the environment. Was I in production? Was I in dev? Was I online? Was I offline? And anything about the environment that would help us. What version of Windows you were running? What other applications were open? Like, oh, the app wasn't downloading anything, but you know what? There was an internet outage that day. Well, then it wasn't the app. What time of day did this happen? Because that will help us pinpoint that if there was some outage, we could possibly correlate it. What did you expect to happen? So don't just tell me it's broken and that's not working. What did you expect to happen? Even if you feel it's obvious, just tell me. And what you actually experienced, your actual result. Those two things can actually be very powerful. So now let's get into how do you solve the problem? And I brought up this checklist because you don't always have to dive into code to solve a bug. Ask yourself these questions. Number one, what changed? If you're running version 1.7 of the app and it's been running fine for a month, and a user reaches out and says this feature doesn't work anymore, but nothing's changed in the code, well, you might want to take a look at other factors because code has no feelings. It doesn't get mad at you, even though sometimes we feel that way. That should be an indicator that if the code hasn't changed, it should continue to be executing, other than maybe like an operating system issue. If you're writing mobile apps, there's an Android or iOS update and it broke everything, or a Windows update came out and broke something. But that's rare. But also, what changed? Let's get back to that question. Look at the change log, right? Go look in your source control. They're running version, let's say 1.7 of the app, but 1.6.9 was out last week. Well, look at the code. What changed? Does their issue correlate with anything that's changed? Um, Off the top of your head, oh yeah, I can see, yeah, if I change that, this thing would happen. Always ask yourself the what changed question. It'll get you to where you need to look pretty quickly most of the time. Next is common knowledge. So you know the application, or at least parts of it. So you should have a general idea based on like the error that they've told you about where this should be happening. And if you don't, or it's in a part of the code that you don't know, you should go lean on your team and find someone who does know that area of the code. So if you could quickly ask someone, hey, do you know where I might look for this? Because you wrote that subsystem. It's better in some ways than you going and trying to figure it out on your own. And at the same time, you're becoming more familiar with that code simply by knowing where to start. So you can work your way backwards, but without going on a super long treasure hunt. And it kind of follows the rules of the pirate ship. You want to have at least two people who know how to do critical functions on the ship. So if one falls overboard, the other one's still alive. Yeah, it sounds kind of morbid, but it's a real pirate ship rule. Um, Working with your team to better understand the parts of the code that you don't know, good thing. But simply asking that question also may save you the time of, well, you're wasting time learning how the code works when you could go ask someone who knows that particular subsystem, say, here's the error. I know that you know this system. They may have an idea and go, oh, yeah, let me go take care of that, or point you to exactly where you need to go. You get the bug fixed much more quickly. Remember, ego. You got to keep your ego at bay. Um, Something I tell my students in the beginning classes is your two greatest enemies are going to be fear and ego. Fear of failing or looking bad to all your other developers, and that feeding into your ego. Your ego will block you from getting bugs and features addressed quickly because you might not be willing to accept where your limitations are. And the fear of failing will also block you. So trust your team, trust yourself, but also trust that you know your own limitations. You'll get better, you'll get past them by working with your team. Next, read the logs. So you should be logging. If you're not logging, you should be logging. You could use nlog, you could write your own logging utility, you can use App Center and Application Insights. There's so many different logging structures out there. There's no excuse that you shouldn't be logging. If someone says there's a bug, you should be able to go immediately to the logs and see the exception. And we will get into that in a bit. And then finally, recognize it might not be your fault. It may not be your code. Your code, like for example, the 170 I was talking about originally, if 170 was working for the past month and suddenly everything stopped working, well, if you didn't release any new versions, hold up. It might not be the code. Let's go find out. Is there a system down? For example, yesterday with the Fastly stuff, you know, Fastly was down. A whole bunch of people were getting a 503 gateway error. Well, if you start looking through your code, trying to figure out why that's happening, but then didn't pay any attention to like any news reports or go to like Down Detector or other status websites, you'd be wasting your time. If it's suddenly unexpected, it's probably not your code, believe it or not. So double check that a system isn't down. And also, did a payload change? These days, we rely on so many third-party services, web services, NuGet packages, etc. The data may change. If you're working on the web, someone might, the service that you work with might change the payload. And maybe you didn't see the document, maybe you didn't see the bulletin come through. Maybe they never sent notification and just did it. Google. Um, yeah, it's it may not be your code. I mean, now it could be partially your code, right? Like you didn't have something in there that would throw an exception when the payload didn't match, or it should have thrown an exception when a payload didn't match. Tried to retrofit the code, just kind of stick it in there, kind of like Newton Soft by default does, and you end up getting a half completed object. But, I mean, it still came back, no error. But then when you tried inserting it into the database, or you tried processing it, some of the fields were missing, and everything blew up. So, always ask yourself, is it our fault or is it somebody else's? and the point isn't blame. The point is the fact-finding mission. So that checklist, what changed? Check with your team and yourself on common knowledge. Read your logs. Is there anything in there about that issue? And is it even your fault? Keep those 4 things in mind, and I think most of your issues will go away. Now, also important is knowing your tools. If you're going to debug effectively, just like any craftsman, you have to have the right tools. Based on the number of hands that went up, I think most of you know what a breakpoint is and what a stack trace is. Does anyone not know what a stack trace is? You know, there's no issue with saying that you don't, but does anyone want me to cover what a breakpoint and a stack trace is? Just raise your hand. Okay. And Shashank, did you raise your hand, or has it always been up? Because I know there was one that was up the whole time. So breakpoints are. Oh, gotcha. Okay, thanks, Shashank. Sorry about that. Oh, okay, I got you, Greg. So we'll go over that and I'll explain it. So we'll skip breakpoints. I'm glad everyone knows about that one. Stack traces, I think, are one of those things that if you didn't know to look for it, you just kind of ignore it, like it's just a whole bunch of gobbledygook. But that's not true. You know, a stack trace is incredibly helpful. So let me go bring up Visual Studio here. Let's see if I can. There's Visual Studio. There it is. Okay, let's see if I can capture my exception here. Well, here we'll go look at a different one. Hold on, let me bring one up. One moment. You won't see anything on my screen yet. I'm looking for something. Boop 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 boop. Let's see, Fisher's test. I'm trying to find an application that might actually be crashing. do. I've had pretty good luck with my apps lately. There we go. We'll look at my my iOS app here. Let's see. I'll just bring this up. And I'll take a look at my diagnostics. Oh, those are crashes. Okay, so the iOS version is working great. Yay! So I'll go back 90 days, see if I have any crashes. Oh, great. Hey, look how wonderfully stable my software is. That's wonderful. Let me go over here. I'll try my Android one. Maybe that one's crashing. Oh, yay. I got a few crashes. Never been so happy. So if you take a look at a stack trace, we'll take a look at these crashes. This, by the way, is App Center. So here's a stack trace. Hopefully you can all see it. Can anyone not? Can anyone see this? Can you see App Center, the website up, and the stack trace? Hopefully you can. So here you can see this died at update main text being called. So you can see this is, oh, there's Steve. Yay. So if you read this, you can see how you got to the crash. So read it line by line, and you'll see what the call stack was. So look at a stack trace as your call stack and where execution died. That's what it means. Let me see if I can show you something over here. I'll just put a breakpoint in here. Hey, yep. Okay. Oh, there we go. Yay. Okay. I'll put a little breakpoint here. Save, run it. So this is just a sample application that I wrote. it just calls a few functions and then throws an exception. It's all it does. Its whole job is to crash. do, 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 do. So in a moment, you'll see it crash. Oh, here it is in the background. Okay, cool. So you can see I went from function 1 to function 2. Function 2 calls function 3, which throws an exception, which then, of course, bounces back to function 2, looking for try catch. And if we didn't have try catch, it would bounce back to function 1, and then main, and then die, because there's no other, there would be no try catch. But in this case, there is one. So here you can see your exception. So catch this. Oh, cool. I got my little recording thing going on. Yay. So if you take a look here, you can see our call stack. So this is how we got there. So we went from main to function 1 to function 2. And that's where we are right now. So this is our stack of calls. If we take a look at the exception, you can take a look and see a stack trace. So if you look at the text visualizer, you'll see the exception occurred here. So I went into function 2 and then it hit function 3. The exception was thrown, and that's it. So that's how you read your stack trace. So at the top here is where it died. Hopefully that explains. The stack trace is the call stack trace. So how did you get to the code that's broken? Here's all the calls that were in between and where it died. And that's what the stack trace tells you. See how you read this? Hopefully that helps you. Now there's nuance to this. Like if you're using like async and await, there's other things that you may need to do to get the actual error. I will say, and I broke my own cardinal rule here. Anytime you have an exception or an exception handler and you're logging, don't just simply log this exception. What you want to do instead is call get, oh, come on. Stop. Oh, yeah, Rev Debug is acting up on me. I like it, but they need to work on some of their issues there. Use get base exception. And the reason for this is that you may have exceptions that are thrown and then swallowed and then continue to be thrown, and it may not, the exception that you're logging may not be the exception that actually caused the error. So it's important to use get base exception, which will just return the current exception if it is the base. So there's no harm in calling get base exception. You'll never get null. So make sure that you use get base exception. Did that explain stack traces for those that want to know about stack traces? Greg, Shashank? Okay, cool. And like I said, there will be time for more questions. I'll turn off the mute all participants function. I just do that because sometimes people leave their microphone on and they don't realize it. It's just faster just to mute everyone. Okay, so let's get back to my slide. Boop, boop, boop. Now, here's another one. Let's take a look. I've got this exception right here, right? So what's happening? Does anyone know what this is called? When I just kind of handle something and then just let it go? It's called a swallowed exception, meaning you're just kind of ignoring it. So if I ran this application, let's say if I didn't have a throw in there and I just caught it and I ran this, so we'll let it run. It'll run, and then that's it. See ya, Allie. Did my application really just run successfully though? It didn't. Really what happened is an exception occurred, but I just swallowed it and ignored it. So what if that's happening in my code and that's the reason that something's going wrong? So I'm handling an exception somewhere, but really what I need to know is an exception happening anywhere? And one thing that you can't reasonably do is set a breakpoint on every single exception handler in your entire application. That's almost impossible. So how do you stop program execution when an exception happens, even if it's wrapped in a try catch? And the way you do that, and I was so happy when I learned about this, is go to your exception settings. And this is under debug and then Windows and then exception settings. And it'll bring up all the stuff that Visual Studio will stop on. And just click this guy. Just make it a checkbox. Just check this guy. And now, even if it's wrapped in a try catch, program execution will stop exactly where the exception is handling, or is being thrown. This is huge because there is a high chance that you have exceptions being caught in your code that you're not even aware of because you're using the default settings. And this will save your life. It'll save your bacon in so many ways. Now, you can go back, see how this is partially checked? Well, how the heck do you get back to, just the options that it had? Just right click it, hit restore defaults. Nice and simple. It was called Sherry, you go to debug and then Windows and then exception settings. Also Control Alt E. But this is, just as good. And now you can see, you're welcome. Now you can see that I've stopped program execution where the issue is. Now, this cool little thing right here, this is Oz code coming up. So I can go in here and in a tabbed interface, view the exception. I can also see if there were multiple exceptions to get to this, how I got to it. I can see the type, I can see the message. I can see where the exception was handled versus where it was thrown. Really powerful stuff. I can see if it has an inner exception. Very easy for me to understand this. I can search for text. So I can say, like catch, and it'll find it for me. Ozcode does a lot more than this, but it's just an amazing tool for for tracking this sort of stuff. Lots of just really amazing things. Now I can continue my execution. and the application will, die like it was before, because it's done executing. Um, but yeah, that is a great time saver, this exception settings. Now, there's a number of other items that you can use if it's REST based. So if you're having service issues, you can use the network monitor in your browser. You can use Postman, which is free. You can use Fiddler. Um, I don't have enough time to go into every one of these, but we do have a video about Postman uh, in our playlist. It was done by Dave Fancher. So just take a look at that one. But like the network monitor in your browser, you can take a look at that. And just let's see, what is it, F12? You can look at your developer tools, and you can see all the network calls that are occurring. So you can see if you got any 500s, see all the 200s here. 200 okay, 200 okay, 200 okay, lots of 200s. This is all good. 200 okay. But if any of these were red and had a 500, well, that's probably, you should go look at that particular call, that REST call, and figure out what the error was, what server was it trying to hit, etc. This is a tracking cookie that was just blocked because of my settings. But we could take a look at, I don't know, fetch. See if he'll show me. He'll show me the result. Oh yeah, that's just an image. That doesn't help me at all. But here you can see like your models that came back. So when you hit this URL and then models, so you see they're hitting the App Center API. You can see what came back. So this is where you can check to see, hey, when I'm using my site, is the right data coming back? Like, oh, that model doesn't look like what I was expecting. Well, let me go and fix that. So very important thing to learn is your browser's built-in network monitor. And then, of course, Fiddler, free tool from Telerik. Definitely get that if you haven't used it. And then Postman is very good for testing API calls, but not for monitoring HTTP traffic. It doesn't do that. If you're on a Mac, by the way, if you're using like Visual Studio Mac, you can use Charles Web Proxy. It's like Fiddler. So Charles Web Proxy. Of course, though, this built-in network monitor it's built in, whether you're using Chrome or you're using Edge. And I know Safari has one too, but I'm not familiar enough with how good that one is. All right. Now, definitely get to know your testing frameworks. And if you're a Microsoft developer, you're probably going to be working with MS Test. But on the Java side and the JavaScript side, look at JUnit and Jasmine. There's a lot of testing frameworks out there. None of these are listed in the order of what I prefer. Just letting you know, you should know your testing frameworks. I just gave you an example of Ozcode. If you work with a lot of link queries, Ozcode will totally change your life. Another cool thing that you can do in Ozcode is you can take an object that's been passed and you can export the object. And so you can take an object at a particular state, like let's say an entity, and right click it and say extract object, or I think it's export. And it'll export the object fully with all the values already set so that you could use that as a test. So rather than hand writing your object, if you know a good condition, you can start up your application, and when the object is populated to a known good state, you can right click it and say export, and it'll automatically create that object, like the code to instantiate it with all of the proper values already populated. I mean, that by itself will save you, maybe hours of time. Rev Debug, I was just showing that to you. It's really cool. If you take a look, you can go to Rev Debug. Although they go back and forth on being a little buggy, but they're very cool, and their server solution is incredible because you can actually use Rev Debug in the cloud, and when an exception occurs, you can pull that exception down, and it'll bring you to the application at the exact same state as what crashed in production. So you can see all the value, like the variable values and so forth. It's basically like a video player for code. So here you can see when did the application start running? It started at function 1. And then, let's see, here, I'll start from the beginning. And run it, step into, you can see how I ran. I must have messed it up somewhere. Oh, here we go. I got to go all the way to the beginning. There we go. Step into my application. And here you can see, okay, well, it's not working. I don't know why it's not working. Oh, I know why. I think I know why. Step into it. There we go. Step into instead of step over. Step into, and you can see I'm running my application. When I'm calling function 3, and then catch this. And then you can see I ended up in my exception handler. And then my application execution ended. Pretty neat, huh? I mean, I just went through the flow of my application without running it. So I could see where the error occurred. And you can actually go to the exception where it happened. You can see here's your handled exception. And it just takes you right there. So it will give you a list of all of the exceptions. And you could click and see them where they happened in your code after you ran the application. So you would see all of the swallowed applications too, without even hitting without playing with any of the debugging settings. And by the way, Rev Debug is free. The server is not, but this version that runs locally is. Very, very cool stuff. Another one is Application Insights and App Center. We'll get into that in a moment. I'll show it to you. You kind of saw that for a moment back here, but I'll give you a little bit more information in a bit. Now, how can you prevent bugs from happening? Because really what you should do is be proactive, help things go right, stop bugs before they happen. And part of that is being prepared. Imagine the person who will maintain your code is a violent psychopath who knows where you live. I think Martin Golding said that, and I think about that often. So don't just write code, write good code. And one way you do that is by planning ahead. Unfortunately, I think like when we learn to code, especially like if you go to school to develop, whether it be a coding academy or college or high school or whatever, they teach you to code, but they don't teach you to plan what you're going to code. And I think that makes us think back asswards that code is the most important thing, not architecture or intent, etc. And we don't learn until later on that architecture and planning and intent, etc. are important and more important than writing the code just by diving in. So, like I said in the beginning, the easiest part of development is code. So, having a plan takes time, but it weeds out the bugs, the issues, and so forth before you write them, because in your head you have a definition of done. You have a compass, and it's putting you along your path. It's your Google map for your code that you're going to write. And maybe a Google map of your application. Next, code with intent. Don't write the code first. Have you noticed the theme? Write the interfaces. What would an object like this do? If I was writing a cookie baking application, I may have a cookie, and well, you got to eat a cookie, but you got to bake a cookie. You have to check cookie temperature. Yeah. What are the things that this object is supposed to do? I should not be thinking about the implementation details. I should be thinking of the intent of the objects and what they're going to be capable of doing. I'll get to the implementation later. I'm wasting my brain power worrying about how I'm going to do it. Really, what I need to know in the beginning is what I'm going to do. Then I can get into the how. And that's where dependency injection and version of control, etc., mocking, all of that comes in. But we're not, that's a whole different topic. This is a bit of a religious war, but I'll wade into it. I am a big fan of comments. I don't believe comments go stale as often as people say. That's like the generic response. Well, comments go stale. Well, but why did you have the comment? At the very least, if there's a complex business rule, don't just write code that implements it. Put the business rule in there and point to the ticket, if you want, that defined it. And it should be the next developer's job, if the business rule changes, to update that comment. It doesn't take a long time to update a comment. If they didn't want to update the comments, that's laziness. Plain and simple. Because there's no way that you didn't have the extra 10 seconds to update a comment. Yeah, we have 10 seconds all the time. Turn off the YouTube video you've got on the other screen. Spend the 10 seconds, and then you can resume it. Pause it, write the comment, resume it. But anyone who tells me that commenting is a waste of time, you should write readable code, apparently has never written anything complex or had to dive into code that they didn't write, and they're like, why the heck is this thing doing it this way? And there's no other documentation. So huge waste of time for anyone who has to maintain your code. Get back to rule number 1. Imagine the person who will maintain your code is a violent psychopath who knows where you live. Write unit tests. If you haven't seen this, a good friend of mine wrote a great series of articles about automated software testing, unit tests, integration tests, system tests, etc. Just go to arctronic.com. Just search for automated software testing part 1 at arctronic.com. What a great write-up. I use it all the time. He was very passionate about why it was important, and it comes across in what he explained. So if you have not read about that, check it out. And a few notes about unit tests. I'm not a fan of 100% code coverage. I mean, if you have unlimited time and unlimited budget, yay. But you don't always have that. But at the very least, if you need to verify that business rules are being followed, why not write them? Like I was saying, you could use Oz code to export the object in a proper state and compare it to actual program execution. It should follow those business rules every time it runs, and you should not be able to deploy it if that unit test fails or that integration test fails. That is important. If it's an important business rule, you should probably have a test around it. Seek pull requests. I'm not a fan of people who don't do a pull request cycle, or approve their own PR, even as a software architect, I made sure that I had someone else on my team, I didn't care who it was, review my code before it went in, even if it was one line. Because pull requests are the sanity check that you need because you are too close to your code. You generally won't see the faults in it. There's nothing wrong with saying, why did you do something this way? You're not making someone feel bad. You should expect constructive criticism, constructive questions out of code reviews in these pull requests. And if you're not getting those, I would check to see why. Why don't we have those? Why don't you have those? Because it'll help trap bugs you never thought about because you're too close to the code. On logs, like I was saying, one of the most important ways to get out of even having a fixed code or to find the problem of where the issue is occurring is in the logs. If you find that you aren't logging something, but you should, fix that right away. Logging should not be an expensive task. So you should be able to log successfully. And anything that's missing, you should fill that gap right away. Any test cases, same thing. If you missed a test case, you should have it. Go at it. And don't put it off. If it's only going to take you a few minutes to add it as part of that pull request. Don't say, I'll get to it. You won't. You're not going to prioritize it in the next sprint. And don't get pedantic. Like, well, it's not in our sprint, so I'm not going to work on it, because I have other things to do. No, follow the rules of help things go right. If I can spend an extra 5 minutes to make my system more bulletproof, I should do it. And I don't think anyone will punish you for it. And finally, use telemetry and analytics. This is effectively free. Application Insights, App Center, they are a phenomenal heads-up display of your system stability from a high-level view. So if you take a look at App Center again, I can take a look at my analytics and see how many people are using my app, how many times a day they use it, and how long they use it. This isn't code. It has business value, but it also has developer value. How many people are using the application at once? What countries are using it? What events are occurring? Now I've noticed, I'm looking at this, what is Android? Yeah. If a new operating system came out and all of a sudden, my usage started plummeting, I might have an issue I'm not seeing. And I would need to look into that. But this is a top-down view of my application and how it works. And you just go to appcenter.ms, you can set this up. This is for Xamarin, but Application Insights does similar things. And then this actually can feed into Application Insights and give you even more information about the users, funnels, user flows, common exceptions, trends, reporting, etc. I can also do diagnostics, look at my crashes. And you can see there's this common issue that's hitting 22 users. And I'm like, I can drill into that just by clicking it. Note that I'm not in Visual Studio. I am just looking through my telemetry and analytics system, App Center. It's free. I can see, okay, which devices are affected. Remember those questions we were asking? What device? What operating system? Important things, huh? So let's take a look. I can even see the individual reports. So I can click at these and say, how did they get here? They started the app they added an entry. This is for my learner's permit log tracking. And then the app crashed. Well, that's not good. If I see this happening all the time, here, entry added, app crashed. Entry added, app crashed. Now I have a feel for what I need to do. When someone adds an entry, it could crash. Then, I can take a look at what the stack trace was. Now this application is pretty old, so I might need to update to the latest version of Xamarin Forms. I haven't updated this app in like 2 years. So chances are I should release a new version that fixes this exception. But this helps me figure things out. When was it launched? Where was it launched? On what was it launched? Using which network? How long they were using the app? What language they were speaking in case it was a localization issue? What OS, in case it was OS specific? And if I had a user ID, so I could even track user IDs if I wanted to. But simply by adding this to the app, I just basically say appcenter.start. I get all of this information. So why wouldn't you do it? So that's App Center, and of course there's Application Insights. If you go to the YouTube, just my YouTube, go to the Indy Xamarin playlist. I presented on telemetry and analytics last month, and you can go learn more about it there. Like and subscribe. And that's all I've got. I hope you learned a lot today. It's a lot to take in, but hopefully some of the feedback and tips and tricks I gave you today helped you out. And let me unmute in case you have any questions. See if I can go back to my participant list and take care of that. Waiting for everything to come in. Can I unmute participants? Oh, I didn't disable the mic for any attendees. So that's good. I guess it was just only camera that I disabled. Yay. Did anyone have any questions? And if you ask any questions, you're welcome to unmute and ask. Where's the YouTube? If you go to that youtube.com/zippedgs, here, I'll put it right here. Oh my gosh, that came up really big. You should be able to find the playlist for Indy Xamarin. Let me and then there's another playlist for Indy.NET Consortium. Yep, I can share my slides. For logging, no, console.write I don't think is good enough for logging. What I would do is I would write a logger class and have it log both to a file or a service and to the console. So there's nothing wrong with writing to the console. The problem is once the execution's complete, or once it, you can't see those logs. So if it's not stored anywhere that's semi-permanent, how do you get that data? And explaining to the user how to get that data can be difficult sometimes. So I would definitely log it somewhere. And if you go and you get something like nlog, I'll just put that right here. It's super easy to set up. It can write to text files and databases and table storage. Although I wouldn't do table storage, it's a waste. It's very hard to query and expensive to query. But you could write to both at once for free. So why not? Just get nlog. And if you can get application insights, go get that. It's free for up to 1 GB of storage every month. You're welcome. Thanks, Shashank. Thanks, Keith. Thanks, anyone who said good presentation. Um, and just if you have any questions about you want to follow up on this, just hit me up. Auri@auri.net. Very simple. And I'll help you out. Feel free to hit me up on LinkedIn or on Twitter. I don't check Twitter as often. Let me get you the URL for the. Let's see. I'm trying to find this for you. Oh, nope. Went to the wrong place. I'm going to go ahead and stop recording, though, because no one needs to hear me typing. So thank you.